Hello, my dear students and the rest of the learners. Welcome to part 5 of a 22-part series of tutorials in Managed Database System using Microsoft Access and SQL. This is part 5 of 22, in which we are going to be learning about how to determine database structure and operations, on determining database structure and operations, and the design basic database topic. My name is Mema JM, or you can simply call me Emily Swap. Let's start by looking at determining database structure. A database is structured in form of tables that are composed of records and fields, where a field is a single piece of data or attribute, or what we call a column of data. For example, first name, date of birth, gender, amongst others, as indicated in the following tables that we are going to discuss. These fields are usually columns in a table. So when we speak about a database being composed of tables, we are simply saying that all the information in a database is organized in formal structures composed of rows and columns that we call tables. And in this table, what is called a row is referred to as a record, and what is called a column, or what forms columns, is what we call the fields. And therefore, we are saying that a field is a single piece of data or attribute in a table. Example, first name, date of birth, gender, amongst others. So the fields are usually columns in a table. And a set of related fields form a record, or a set of related records form what we are calling a table, while a set of tables that are related form a database. And therefore, any information in a database is found in specific tables. A record, just as I have said, is a row of data in a table. For example, if you have a table called students in a database, for example, by the name Emily Swap School database, this record will be composed of a number of fields. And in this case, as we are going to see in this presentation, each row or each record is composed of 9 fields. And these 9 fields, or this record, single record, in the students table will compose a single students. So these fields include student ID, first name, last name, DOB or date of birth, gender, phone, email, address, and program ID. You can thus have several rows, especially when you want to enter details for several students in a table. And in this case, I repeat, each row in a table is called a record because the information that we store in that row concerns, for example, a single person or a single subject or a single entity, or what we call a sub-entity. A record contains details of a single student in our table. When you have entered all the required details for other students, that is several rows, depending on the number of students, then what results is a table. So in other words, what I'm saying, and I'm emphasizing on this aspect of a table, is that a table is not composed of a single record. A table is composed of several records, and therefore it is composed of several rows, and of course, several columns, because you cannot have a record being composed of a single field. For example, the Emily Swap School database that we are going to create will be composed of the following 6 tables, with each table being composed of a number of records and the fields as follows. So in other words, we are saying that a database is composed of a number of tables, and the number of tables that you have for your database depends with the amount of information that you want to store in that database. So in our database called Emily Swap School that we are going to create and that we have been discussing since part 1 of this series will be composed of the following tables and organized as follows. The first table is called the students table. And the students table will contain the following records. So, my dear students and the rest of the learners, it's important for you to note that this name, students, is the name of our table. It is this name. And then these headings is what we are calling the fields. The fields. So in this case, our students table, as you can see, will be composed of those 9 fields. And these 9 fields are student ID, first name, last name, date of birth, gender, phone, email, address, and program ID. So ordinarily, in a relational database, for example, when you create a database using Microsoft Access, that is the format that our tables or each table will take, and the number of fields will depend with the type of information we want to hold in a single table, and also the number of records will depend with the number that we want to store. And therefore, these fields form the records. For example, the first name or the first field called student ID, in this case, will have a S001. That means the first student ID. Then first name is Jane, second name or last name, Jerry. Date of birth, that one. Gender is F for female. This is the phone number for Jerry. Her email is this. Her post office box is this, or the address. And the program that she will be taking is a program ID that is called P001. Then the next student is student ID S002. First name, John. Last name, Mwangi. Date of birth is there. Gender is M for male. This is the phone number. This is the email. This is his address. This is his program ID or the code for the program that he will be taking. And therefore, my dear students and the rest of the learners, you can see very clearly that for each table, we have a number of fields, and each record is composed of all the fields. So if you pick, for example, this row And then you look at the information that has been stored in this role. All this information is for a single student. So each record, as you can see, is composed of equal number of fields. You can see, if I pick S007 and I pick the first student here, student ID S001, you can see the number of fields are the same, but the content is different. The number of fields are the same, but the content is different. It is a content which is different in this case. So this table of ours called the students table, as you can see, it's holding, or it will store records for 7 students. Each record represents details for a single student. So we have 7 rows. We have 7 rows, with each row having a certain number of, or with each row having details for a single student. So this is the first student, second student, third student, fourth student, fifth students, sixth students, and seventh student. That is a very important characteristic or features of tables. So tables are composed of records, but a record is composed of fields. So we move from table, like this case is students table. Then we go to the records. From records, we move to fields. Then from the fields, we go to the specific text for each. So this is students table, our first table. Then we move to students or programs table. If you look at programs table, it has a different set of information, but you can see there's a field which is similar to the field which we had in the first table, in the students table. That is the program ID. You can see we have a field that is similar or that is common. So the student ID, if you move to the first or the first table, students table, we have seen that this students table has this field because each student is enrolled in a certain program or is registered for a certain program. So if we move to the next table, which is our table number 2 for programs, you can see that now we have the details for the program. As you can see, we have program ID, we have program name, we have program fees, we have the duration, and we have the department. So this student who was having program ID P001, it means that she had registered for a program called Diploma in ICT. Amount of fees, this amount. Number of years, this. And the department ID is here. And therefore, my dear students and the rest of the learners, it is important for you to note that each table owns a specific set of information. The first table that we have looked at, the students table, contains details about the student. It contains details about the student. When we move to the programs table, you can see this table contains details about the programs. Here we have 5 programs: Diploma in ICT, Diploma in Business, Certificate in Education, Diploma in Electrical Engineering, Certificate in Engineering. So this table contains details about the programs that in this school. So we have the program ID, we have the program name, the fees to be charged per program, the duration that each program will take, and the department ID, which indicates the department in which the program will be being offered from. So it is good to note, for you to note, that we have added the department ID. But we don't know by now which departments are these that are going to be hosting these programs, whose cost is this, and their identification code or codes is as you can see. So it is our expectation that next we are going to find details about these departments, where these programs are being offered from, or where they are based. And therefore, this programs table contains details about the program. And of course, an additional field called department ID to show the department in which these programs reside. You can see that what we are using, or what we shall be using in the subsequent tables, whenever a program will be required, will be the program ID field. And whatever shall be using to represent departments will be the department codes. We have department 001, 002, 003, 004, 005. So we shall see which departments are these next or later. So this table contains details about the programs. So it is composed of how many records? 5 records. 1, 2, 3, 4, 5. And remember, a record is the entire row. A record is the entire row. And each of the columns represent the field. So we have how many fields in this table? We have 1, 2, 3, 4, 5. So these 5 are the fields. And if you pick a certain field, for example, this field called program name, you can see the details are the details for the programs. If you pick a field called, for example, duration, you can see this is the field. So the details or the information there in that column, what we are calling a field, are the years. So this is how we organize the information. Later on, we shall see how we arrive at these tables. Our third table is courses table. Now the courses table, as you can see, is composed of the following number of courses. It is composed of the following number of courses. We have 1, 2, 3, 4, 5, 6, 7. Those are 7 courses. And each course has its own identification code. The number of credit hours for each. And you can see something here. Because these courses are resident, or these courses belong to specific programs, we have introduced another field called program ID to show that, for example, introduction programming is a course in a program called P001, or whose code is P001. And we have already seen what P001 stands for, what P001 represents. If you've forgotten, you can see, let's go to the programs table. P001 is here. This is P001, so it is diploma in ICT. My dear students and the rest of the learners, I want you to see the relationship between the tables or how we create the tables. And how we introduce a field that can connect between one table and the other. And therefore, this table is composed of, the courses table is composed of 4 fields. 1, 2, 3, 4. And how many rows or how many records? 1, 2, 3, 4, 5, 6, 7. Of course, a record runs from here to there as a record. So we have 7 records and 4 fields. Let's move on to the next table. Next table is called enrollment table. Now, what are we finding in enrollment table? The enrollment table, first of all, is composed of how many fields? We have 1, 2, 3, 4, 5. So the details here are for the students. For the students, the courses they have enrolled in, the year of enrollment, and the term. That is purely what is here. So this table simply indicates the students who have enrolled for certain courses in a certain academic year or for a term in an academic year. So these fields have a meaning. So we have student ID, we have course ID, we have academic year, we have the term. And of course, the number of records here are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 records. So the enrollment table contains 11 records. 11 records. And we can see which student's admission number has enrolled for a certain course based on the course code and the term. We move on to the next table. Our next table is departments table. So the departments table purely contains the department names. So you can see in the departments table, we have the department ID and the department name. This is very important because, for example, under the courses table, or let me move to the one which has the departments, under the programs table, we have the departments filled here. So, and these departments were identified or have been identified using department code. So the table for departments gives now details about those departments. So D001 is ICT department, 02 business, 03 education, 04 engineering, 05 hospitality. So the departments table is composed of 2 fields, but those 2 fields are forming 5 records. So we have 5 records. So we move to the next table. Our next table is called payments table. This table is purely containing information for the students and the fees they have paid, including the mode of payment. So you can see we have how many fields? We have payment ID. Now when you are paying, the receipt is given a number. So payment ID. Then who is paying? The admission number of the student ID. Which date has he or she paid? It is there. How much has the person paid? And which mode? Is it M-Pesa? Is it in cash? etc. So the payments table purely indicates, or its purpose is to indicate who has paid how much. Who has paid how much and in which day. So that is all about our tables. So what are some of the operations that you can perform using a table. Once you have created your tables in Access, you can then proceed and perform some operations such as inserting new records, selecting records that meet certain criteria, updating records, deleting records, etc. Either by using a wizard query, a SQL code, or other methods as necessary. We are going to be seeing how we perform these operations in the subsequent presentations when we shall be creating our actual database. So for example, the following are some SQL codes that can be used to perform some operations. You don't need to internalize these, but they are good for you. So one of the operations you can perform is operation for inserting fields in or inserting records in a table. So insert operation is used to add new records in a table, either through a form or datasheet view or using SQL. And an example of SQL language is like this. Insert into the students table and the first name field, last name field, date of birth field, gender, phone, email, program ID, and enrollment date, the values, Alice for first name, Mugo, last name, the date is there, the gender is female, the phone number is there, and the email is there, and the duration is there, or what we are calling not the duration, but after the email, we have the program ID to date is there. So don't mind about this SQL language for now. We shall discuss this in our subsequent presentations. The next operation you can perform is select. Select is used to retrieve records using a query or using SQL. So this is an example of SQL code which you can use to select records. But simply, you select records from a database. You select records from a database using a query. And we are going to see how we do that. That operation is update operation. What does it do? Updating a database simply means that you want to modify or change existing records. And this can be done, for example, using update query, or you can also use SQL, like this code here. This is SQL for updating, where this information says, update the students table by setting the field code phone number with this value, where student ID is that. So in other words, this is an SQL code which does what? Which tells the processor to go to the table called students, then the field called phone number, and insert into it this data, but under the field or under the record whose student or whose ID is this. So in a nutshell, or in simple terms, this SQL code is telling the processor to make changes to the table called students and the field called phone number for student ID ST1001. This is just an example. We are going to see how we do this later in our subsequent lessons or presentations. Another operation is delete. Delete is an operation which is used to remove unwanted records. And this can be done, for example, using delete query or by using an SQL code like this, which say delete from the table called enrollments, delete from the table called enrollments, the record whose enrollment ID is 5001. So you remove that record. Another operation that you can perform is, in addition to delete, in addition to update, in addition to select, in addition to inserting, there are other operations that you can perform in a database. There are other operations like developing or doing what we call a calculated query or a calculated field. You can perform operations for computing values, adding data from more than one field, and creating what we call a calculated query, amongst others. So these operations, as I have said, can be carried out in the database using the SQL programming language or just by using the query wizard that is appropriate for the purpose. For you to be able to code the SQL programs for performing these operations, while your database is open, you have to switch to SQL view, and we are going to see how we do that in our 14th presentation this series, where we are going to be learning about how to create queries in Design View, and at that point I'll also demonstrate how we do the SQL. The beauty with Microsoft Access database creation is that once you have created, for example, your queries using a wizard or even using the Design View, you can be able to run or generate their respective SQL code. We are going to see that. So at this level, we are not really going to be writing any sequence of code using SQL. Most of our work will be related to or will involve making use of Microsoft Access using wizards or using Design View. So you can therefore access this video on creating queries in Design View, and more so learning how to deal with or how to generate SQL from the video by the title Creating Queries in Design View by Emily Swap, which is presentation number 14 in the series. And this can be found in Emily Swap ICT YouTube channel. So let's see some examples of the queries created using SQL language. And we also have a look at how the SQL to generate those queries looks like from a database that I'm calling Emily Swap School. So let me open a database here. I want to open the database. This is our database that I want you to see. Now, this database contains a number of objects. We have tables, which include courses, departments, enrollments, and of course, we have seen this in our presentation. So this is courses table, and you can see the ones we have discussed. This is departments. This is enrollments. This is payments table, the one we have already discussed. This is programs table. This is students table. So that's how our tables look like in the real language Microsoft Access application. Then for queries, these are queries here. We have query for balances. If I open it, this is our query. Now, for us to be able to see the SQL for this query, the SQL or the SQL for this query, we click on this button here, and then we choose SQL View. You can see this is how our SQL code will look like. Then I want you to see this other one, a query, which I'm calling query fees paid, to show the fees paid. So this is how the query looks like. This is the query. Now, the code to generate this using SQL is this. So this set of statements here, select students.studentID, comma, students.firstname, etc. This is the code that you write in SQL to generate this query that you can see. Because if I run this SQL code by clicking on run, you can see what it will give us. Then we have this other query here. This is how this query, the results of this query looks like. These are the results of the query. Now, the code for this query is that one. So you just generate it, or you can just code and then you run. If I run this code that you can see on my screen here, select students.student ID, comma, students.first name, students.last name. Simply, this code is saying, go to the table called students, select the students. Then access the following fields: student ID, the first name of the student, the last name of that student. Then go to the table called the programs and choose from there the program name. Go to the table called departments, choose the field called department name. And then once you have made those selections, display the results on the screen. So if I run, you can see we are getting first name, last name, program name, departments. Let me close this. We are going to work on this in my subsequent presentations, and let's see how this other query works. Now, this query, you can see once you open it, it is prompting for a student ID. For example, this ID is 001. If you press OK, you can see what it has generated. It has generated a single student. So in other words, this query, the purpose of this query is to display a student, a specific student, to show the course that he or she has enrolled into. So S001 is Jane Jerry and has been registered in a course called Databases Academic Year 2024. So how is that code in SQL? This is how the code to do that looks like. Select enrollments.student ID, comma, student's first name, student's.last name. In other words, this code means go to the table for the enrollments, pick a student ID, the first name, that's the student ID, the ID which has been entered, then access the first name of that student and the last name, then go to the table called the courses and choose the course name, and then go to enrollments table and select the academic year, display, and also go to the departments, go to, not the department now, I repeat, go to the table called students or enrollments, go to the table called enrollments, choose the student ID from there. Then go and pick the first name, the last name of the student from the students table. After that, go to the table called the courses and pick the course name from there, and then go to the table called the enrollments and pick the academic year. So when that is compiled, display it on the screen. But who are you displaying on the screen? It is the student whose ID number or whose admission number or whose the ID number has been entered. So you can see where enrollments plus student ID is equals to enter student ID. So in other words, you enter the ID of the student so that then from there, the rest of the code can be generated. And therefore, we can close that. And then let me exit from that database. And then we go back to our demo. So with that, my dear students and the rest of the learners, we have come to the end of part 5 of the series. You can now proceed. You can proceed to part 6, in which you are going to learn about how to implement database design through normalization. In other words, the next presentation in this series is very important because it lays the foundation for database creation, and it is in it that we are going to learn about how to do what we call database normalization. The data we have discussed has already been normalized. So how do we normalize? That's what we are going to learn. So congratulations for learning part 5 of 22 on determining database structure and operations in managed database system. You can access the rest of the parts in the series as well as other computer or ICT videos by clicking or tapping on Emily Swap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emilyswap@gmail.com. Thank you very much for listening to me. Let's meet in part 6 of the series, and God bless.